All right, this is Chapter 10, Lecture 8. And Chapter 10 is titled Calculation of Medication for Special Populations Based on Body Weight. And I am going to pick back up on my lecture from Lecture 7, and we're going to now pick up Example 10-7. So if you are following me within your book, look at example 10-7 that is on page 361. All right. And let's just go ahead and read the information. So it first says a physician orders amoxicillin 3 times a day for a child who weighs 50 pounds and is 45 inches tall. The normal adult dose is amoxicillin 500 milligrams 3 times a day. So I'm going to pull out the information. Well, first off, I know that the doctor has ordered amoxicillin TID. All right. The patient is what? 50 pounds and 45 inches tall, and it tells you that the adult dose, I'm going to put AD, the adult dose is 500 milligrams 3 times a day. So the first question that it asks of you, so question A, they want you to let's first, before I even do that, let's just first determine the dose order for the child. Well, in order to do that, all right, the doctor has ordered amoxicillin 3 times a day, but they haven't said in detail how much of amoxicillin, right? So the first step is we have to look at the information that's given to us. Well, the information that's given to us is that the patient is 50 pounds and is 45 inches tall, and that it has an average adult dose of 500 milligrams 3 times a day. Now, you could say that you would want to use one of the pediatric formulas. And in this case, you would say, oh, well, I could use the Clark's rule. But unfortunately, we're not going to use the Clark's rule because the patient's information is just not off of weight. It's based off of weight and height. So your first step is to determine the body surface area for this patient. And the body surface area for this patient, you're going to take the square root of 45 inches times 50 pounds and divide it by 3131. All right. Now, I'm not going to show you guys step by step because I think I've done that so far. But what I want to do now is I just kind of want to just give you guys the answer. But if you take 45 times 50, that's what, 2,250 divided by 3131. You're going to take the square root of that entire number, and your answer should be 0.85 meters squared. Remember, you always round your body surface area off to the 100th place. Now that you have determined the body surface area, your second step is you must use the body surface area dosing formula to determine the dose order. So that formula is, I want you guys to make sure you write this down. And that dosing formula, this body surface dosing formula, can also be considered an additional pediatric formula. But that formula is where you take the body surface area of the patient, which is in meters squared, over 1.7 meters squared. The 1.7 meters squared is the average adult body surface area, and you multiply that by the adult dose. So I'm going to calculate this to be 0.85 meters squared over 1.7 meters squared, and you multiply that by, what was the average adult dose of the amoxicillin? 500 milligrams. Your answer should be 250 milligrams. This is your what? This is your dose ordered in detail. So I've answered A. For me to determine the dose ordered for the child, I first had to determine the patient's body surface area, and once I determined their body surface area, I then had to use the body surface area dosing formula, which is the body surface area over 1.7 meters squared times the adult dose, to determine what that dose ordered is. All right. The next question . All right, so C, or B, let me say. Let's go to B. They want to know what volume of medication will provide the calculated dose order. So in order to calculate that, you have to use the formula method, where you take dose order over dose available times the quantity. Well, you guys calculated the dose ordered to be 250 milligrams. The dose available of the medication is 250 milligrams times that 5 milliliters. Milligrams cross out. So the patient's going to need 5 milliliters per dose to provide that dose ordered of 250 milligrams. All right. So now that I have shown you guys the example 10-7, let's go ahead and try some of these practice problems. And I want you guys to turn to page 363. All right. And with page 363, these practice problems, it's basically, they want us, the instructions state for us to calculate the following problems using body surface area. Remember to obtain the body surface area and then insert into the proper formula. Use the same formula for body surface area for adults who do not meet the standard weight and height sizes. Show your calculations, round to the nearest hundredth for dosage, round to the nearest tenth for volume, and you can use a calculator. So for practice problems D, starting on page 363, let's look at number 1. And it tells you that a child, I'm pulling out the information as I'm reading, is 25 inches tall and weighs 15 pounds. The physician orders, so I'm going to put RX, Lanoxin daily. All right. The adult dose is Lanoxin 0.25 milligrams per day. Okay. And it also tells us that the available medication, what you have in stock, is Lanoxin 0.05 milligrams per milliliter. So the first question, A, says to calculate body surface area. Well, we're not going to use the nomogram. In order to do that, you're going to use the body surface area formula, where you are going to take that patient meters squared, where you take that patient's height in inches times 15 pounds over 3131. So I use body surface area formula number 2. You're going to take the square root of your entire number and round that body surface area to the 100th place, and your answer should be 0.35 meters squared. Okay? So, question B says for us to determine what is the daily dose strength of Lanoxin for the child. So they want you to calculate the daily dosage. So basically they want you to calculate the dose order. So based off of what you've been taught, based off of the information that's given to you, you have the average adult dose, which means that you must use the body surface area dosing formula because it's giving you the average adult dose. That dosing formula is where you take that calculated body surface area of 0.35 meters squared over 1.7 meters squared, and you multiply that by the average adult dose of 0.25 milligrams. So if I take 0.35 divided by 1.7 and multiply it by 0.25, your daily dosage for this patient, they want you to round it to the 100th place, is 0.05 milligrams. Okay? I need to make room to answer C. So we're going to use a new, I am going to use a new document to answer C. So C for number 1 under practice problems D, they now want you to, they're asking you to do what? For C, they want you to determine, the question is, what volume of medication should be administered to the child. They want you to determine or calculate the volume per dose. In order to calculate that, you must use the formula method. Where you take dose ordered over dose available times the quantity. So in this case, your dose ordered, you guys calculated that to be 0.05 milligrams over the availability of the drug. What you have in stock is 0.05 milligrams, and you multiply that times 1 milliliter. Your answer for number 1, question C, is 1 milliliter. All right. That is the end of lecture 8. All right. I want you guys to keep working on these practice problems. So far, I've basically just about done every practice, not every practice problem, but an example of each practice problem. If you have any questions, just give me a quick call or email. All right, this is the end of Chapter 10, Lecture 8.